Delighted to be anchoring today's session of the Digital India Dialogue series. The series is a collaborative initiative supported by National E-Governance Division, Ministry of Electronics and IT, Government of India, United Nations Development Programme, and India. To set the context of today's session and the keynote, may I please invite Mr. Vinay Thakur, Chief Operating Officer, National E-Governance Division, Ministry of Electronics and IT. Sir, you also hold the charge of Additional Director General, Bhaskaracharya National Institute for Space Applications in Geoinformatics. We request you to tell us more about the program, its progeny, and future plans. Over to you, sir.
Yeah, thank you so much, Swati. Very good morning. Would like to thank all the organizers, Meena Saab and the team, which is running this program of Digital India Dialogue. And would also like to welcome other speakers, Professor Shukla, Shubhendu, and Marina, and all the participants. India has progressed well in the digital transformation, and this era of internet and digital technologies, we are able to bring about and do a lot of large-scale digitization in the country. Whether it is land record or NREGA, PDS, GST, and elections, so big databases have been created, but they were created using conventional technologies. Similarly, in banking system, insurance, and all, those things are being done and computerized, but then records of these transactions are still being managed in a centralized fashion. So, so new technologies have come, so they can also be used to make your system better. So blockchain is one of them, which is a powerful technology, creates a distributed digital ledger, a database, which allows multiple parties to engage in securing and then creating the trust without any intermediary. And this create a trust by acting a shared database. So the multiple agencies within that ecosystem share the database, have it distributed system across the vast peer-to-peer network. So this implies that no individual entity can own a blockchain, and no single entity can modify any data unilaterally. So this is very, very important that everyone needs to contribute in this system, in this technology. So new data can be added in blockchain, but then only through agreement. The consensus, which the key for that is well written, that, okay, so these are the rules for ensuring that there is a consensus. So that is very, very important in this technology. Further, that the information stored in blockchain are time-stamped, stored in a chain, and this extends infinitely, and new data is added to end, and once it is added, it is going to stay permanent. So the record which is already entered cannot be removed, cannot be modified. So that is a big feature of this technology. This technology uses the technique of mathematics, computer science, cryptography, and where each and every transaction, each and every record into a system is digitally signed, and with unique digital signature belonging to the user who initiated that transaction. And but these signatures are, though they are held privately by that person, but then there can be verified publicly. And this cryptographic system, which is used in blockchain, creates accountability while preventing identity fraud, and send any asset or update any information on a blockchain. So you cannot deny that you have not done it, because your digital signatures and all other details are taken into the system. So thus blockchain has a potential to revolutionize the interactions between various players in the ecosystems, government, businesses, and even the citizens. So we have a two type of blockchains, public blockchain and a private blockchain. Public blockchain, where anyone can come. It is not anyone can come, but then he also has to come with this digital signature and his identity established. So like a Bitcoin is a public blockchain, but then in the government, while we started working on few POCs, we thought of going for a private blockchain. So private blockchain are one where we give the permission for the nodes to come into the system. So like we were working on land record where multi-purpose cadastral system was, a POC was done, where all the stakeholder in multi-purpose land record systems, whether it's a revenue or registration or land acquisition or revenue codes or banks or panchayats. So everyone can contribute right now in a conventional or available process. Only revenue is the authority which maintains. So everyone has to send either a almost a physical record, physical copy of it, and only revenue will is going to maintain and keep track of everything. So in a new system where blockchain can be used, everyone can contribute, and it can be consensus at a time when the person goes for taking a loan. So he can directly apply, and bank also can update the land record database where it can be stored on the blockchain. So these are some of the applications type of blockchain. So as I was saying that it has the potential to transform and the entire ecosystem, entire industries and economies of the world. And it is estimated that blockchain technology uses could generate around $3 trillion per year in the business by 2034. So in next 12 years, the technology usage is going to be around $3 trillion using the application using blockchain. And as per World Economic Forum report, it says that 10% of global GDP will be stored on blockchain by 2025. So, and blockchain is going to be one of the 7 big technologies to be used in the processing of the government, whether it is AI, AR, VR, drone, or some other type of technology, 3D printing. So what are the possible applications in India? As I was saying, that we have achieved large scale digitization. So there are challenges. Challenges definitely still challenges of scale, though we have some of the application on the population scale. Aadhaar, CoWIN, Arogya Setu. So these are the big applications. NHA, Ayushman Bharat. But then still, there are a lot of challenges. Some of the applications we are running at very small size, some location, district level. So that needs to be seen, and then see to it that we are able to introduce not only the digitization, but also the trust into these IT-based systems. So blockchain is going to impact. So blockchain should not be used everywhere. So there are some areas where blockchain can be used where there are multiple agencies. The big ecosystem is there, like cryptocurrencies. Everyone knows that it is shared data services where multiple logistics. So multiple people are contributing to the system. Smart contract applications like land record, decentralized marketplace where many seller, buyer, multiple places are contributing into a system. Authenticity tracking, digital identity applications. So these are few of the applications where probably we can use blockchain. So land record, I have already told, is one very good application, and Professor Shukla is already doing a few POCs. And the other day when we were discussing with him, they are doing some application on registration with the government of Karnataka. So that is one very good application, which probably we have to use this technology. Shared databases are another where we should use blockchain, such as the logistic, shipping companies, custom authorities, cargo owners, freight forwarders. So these, everyone contribute into that shared database. So probably that is another application. And one of the example that world's largest shipping company, Maersk, partnered with IBM to use blockchain technology to track the goods traveling across the shipping system in the world. So their things going across in the world, probably the tracking, they are using blockchain. Land record is another application which even Andhra Pradesh is using. but then it is also a limited scale, and it is a private blockchain, permission blockchain, and they came out with some POC, so that is welcome step, but then probably not a full-fledged version of blockchain, which should be rolled out, as I was saying, the multi-stakeholder, where all the stakeholder into a revenue system or land record system could be made a part of it. Voting is another area where probably we need to try online voting or e-voting probably. And there are few countries like West Virginia, they offered a mobile blockchain enabled mobile voting app in 2018 to oversee the voters to cast the absentee ballot. So probably the people who are located somewhere outside. So for them, they created a app which was a blockchain enabled so that the voting can be ensured. Even South Korean government also announced that it is going to use blockchain for electronic voting. And in India also, we had a few meetings at election commission level where they are also looking forward that how this technology can be used out there. So these are a few of the possible use cases. Supply chain is another big use case probably where we need to see. You can see a lot of spurious drugs entering the supply chain. So probably that is another application where we can see to it that how blockchain can be used, how we can ensure the great visibility and traceability into the origins of medicines, and how they can be handled throughout their journey in supply chain. So organic farming, organic supply of things. So Ministry of Agriculture was very keen that how in that organic products into market. So that application can also be put on the blockchain. So these are few of the applications, and I'm sure the speakers who will be speaking after me will be throwing much more light into because few of them are the practitioners who are actually working on developing various applications. So it is going to be very, very interesting, I think. And we hope that this event, this small workshop is going to be very, very useful. We have around 120 participants already connected right now, and they are going to definitely see to it that what are the possible use cases, and then they can further work it out that these applications, this technology can be used further at the state levels also to see to it that we are able to better secure our system and then ensure the trust into the systems further, whether it is cybersecurity based applications or whether it is land record based applications. So these all can be implemented. So I wish all the best to everyone and hope that this is going to be very, very interactive and very, very useful to everyone. Thank you so much.
Indeed. Thanks a lot, sir. Thanks very much. And now I'm going to request Professor Sandeep Shukla to deliver the keynote. Sir, you are an IEEE Fellow and ACM Distinguished Scientist. You are currently a Professor of Computer Science and Engineering Department at IIT Kanpur. You're also editor of ACM Transactions on Cyber Physical Systems and Journal of the British Blockchain Association. Before joining IIT Kanpur, you were a professor at Virginia Tech in the USA. Over to you, sir.
Hello, everybody. Can you hear me?
Yes, sir.
And you can see my slides.
Not as yet, sir.
Okay,
We can
let me share it. I think I did not share it correctly. So how about now?
Yes, sir, we can.
All right. So so I'll try to be very, very brief because we have only about 20 minutes. So what I want to talk about is blockchain as enabler of trust and e-governance. So the idea what blockchain can do can be also done with a centralized system, right? So you have a server and clients communicate with the server, and then the server will do the data processing and respond to the clients and so on. What happens with this kind of setup is that there is a very little trust because there is only one entity that is making all decisions. And also there is a possibility of manipulation from the stakeholder that maintains the server, and there is insider attacks possible. And therefore, what happens in a distributed ledger technology is that you have multiple different stakeholders. They are running a system of servers or nodes, and this set of nodes actually maintain the entire transaction history together. And they also go through a process, what we call consensus, through which it is made sure that each person or each node actually has the same information in the same order. And that's where that particular data structure is called the blockchain. Everybody has a copy of the blockchain, and any kind of attempt to tamper with the information or the history of what happened, be it transactions or be it other kinds of information that you put into the system, the others will not agree to it, and therefore unless the majority of them collude, and also there is a cyber attack on majority of them, it is ensured that the history, the integrity of the history is maintained, and the transactions are therefore non-tamperable as well as they are final. So, so therefore, what now happens is that this gives us a platform through which we can enable trust in our system, and this is very, very important for many applications, including e-governance applications, because many times when we do property registration or when we do various kinds of other kinds of applications, we see that there is often since all the data, the fiduciary of the data is some government entity, and there could be mistakes, there could be intentional changes made to the data, and therefore when you come back and try to find the records in the system, it may have been changed. And because of that, it makes sense to actually ensure that we have trust. Now, the trust can be enabled the best if it is fully decentralized. Everybody has every node has the power to actually ensure that every history and every transaction is validated and every history is tamper-proof. But normally what we have compromised is that between centralization and decentralization, there is a whole spectrum. And normally we set the system into the in the middle or more towards the decentralization, but full decentralization like in Bitcoin or Ethereum is not always necessary. So I like to talk about our national blockchain project, which is a project funded by the National Cybersecurity Coordinator's Office. And we have developed certain applications with blockchain after quite a bit of research in the first 2 years to choose the right platform, customizing the platform, and then we have gone into actually developing applications for various government entities. So the 3 projects that I want to quickly walk you through is the land records management project, the self-sovereign identity project, and the advancing e-procurement project. So, so self-sovereign identity is some method by which you provide identity to individuals such that the individuals have now full sovereignty on the data. So the data that is that the user has, whenever he wants to prove that he has this data, his identity so and so, then what he needs to do is that he has to send that information to another to the verifier directly from his phone or handheld device, and therefore the user's identity is established through cryptographic verification. So therefore, there is no need to go to the centralized, location. Like, for example, when you do eKYC with Aadhaar, you actually have to send your fingerprint, you have to send your OTP, etc., to the server. and then the server actually makes sure the checks that it matches, and then a server tells the verifier that the verification is completed or not. But in a self-sovereign identity system, the entire information is with the user, and the user basically in a wallet, in a cryptographically secured wallet on the user's phone, or it can be a smart card. It doesn't have to be a phone, and therefore the user can actually directly verify. And the way the verification happens is that every piece of information on that identity document is individually signed by the issuer of the identity. In case of Aadhaar, for example, it could be the UIDI that signs with the private key of UIDI the information. And the public key of UIDI would be looked up by the verifier, or it might be actually cached at the verifier, and the verifier can check whether each piece of information sent as identity document is actually verifiable using the public key of the issuer of the identity. So, so the user, for user self-sovereign identity means that data is under its complete control and ownership, and the user can select which pieces of information he or she wants to give. For example, if I have to go and prove my address to the hotel where I'm checking in, I don't need to give them complete other information. All I need to send them cryptographically signed address and cryptographically signed photographs, so that they can, and the name, so that they can name with the booking, and they can match, they can record the address, and they can actually check the photograph for identifying me. They don't need to know my birth date. They don't need to know my other father's name. They don't need to know any kind of other information. So this is what is called a selective disclosure. And since each of this piece of information is signed, so they can individually verify each of this information. So these are called verifiable credentials. So you can actually create verifiable credentials out of other driving license, PAN card, your degrees, your various other documents that you can have, to prove your identity or to prove your credential. It doesn't have to be just identity. You may want to prove that I have a bachelor's degree from so-and-so place, or you might want to prove that I have a certificate in cybersecurity from so-and-so. All that can be done totally under the control of the user. And this verifiable credential format has been standardized by World Wide Web Consortium. So there is, anybody can actually design a verifier software, program that can be used for verification. And this data is stored in a wallet that is cryptographically secure, and also the data is encrypted, and you can actually, in some cases, you can even do what we call zero knowledge proof. For example, if I'm going into a bar, or if I'm trying to prove that I'm a senior citizen, I don't need to give you my exact birth date. What I need to do is give you a proof that I have that, I'm in that age bracket. And therefore, what can happen is that you can send a zero knowledge proof that I'm above 65, whether I'm 67 or 70 or 75, I don't have to reveal. I only have to prove to you that I am above 65, or I'm above 21. All that can be done with zero knowledge proof. So how is this system developed by us? So we actually created this public permission blockchain using Hyperledger. And this blockchain, where every issuer will register their credential schema. So if I am UIDI, I will actually, I will publish the schema of my identity document, like what kind of information is there, in what order, etc. And I'll also put the public key of UIDI on the blockchain. And thereafter, I will start issuing documents or credentials to holders. So first time I may have to do a real other KYC, and then I can get other UIDI will send me my credentials, but not as a paper, not as a PDF document, but as a verifiable credential, where each piece of information is individually signed by the private key of the UIDI. So as a holder, now I have full sovereignty on my credential. So I can now go to a place, for example, I want to go and prove to my university, my other identity. So what I'll do is I will go and present the proof, where the proof is presented by doing a peer-to-peer data transfer between my phone and the verifier's phone or verifier's computer, whatever it is, where the verification software is running. It will actually then, the verifier will then go to the blockchain and figure out the public key of the issuer and the schema of the information that is being issued to by UIDI, and it will then go and do the verification of the proof. So this way, now this access to the public blockchain by the verifier has to happen once in a while, because he can cache, for example, the most common issuer like UIDI or the PAN authority or some other entities. Their public key can be actually cached by the verifier, and therefore the verification can happen offline. It doesn't have to happen online, but time to time the verifier has to consult the blockchain for the public key, because the public key may change. So so therefore I can for example get degrees in the same way. So for example, recently IGNU used our system to give to 63,000 people. They gave degrees and certificates using this system. And there what they did is IGNU issued their public key and degree schema to the blockchain. This blockchain is maintained by multiple institutes, including ours and IIIT Allahabad and IDRBT. We are onboarding now various other entities. So therefore this blockchain is actually multi-stakeholder blockchain. And there anybody who wants to give a degree, they can get a permission to access this blockchain and put their degree schema and the public key. And therefore, thereafter, it can issue the digital degree in form of verifiable credential. And then whenever the student goes to an employer or to go to higher studies, etc., or they want to prove their credentials on LinkedIn, etc., they can actually, those entities can actually work as verifier. And all they need to do is to actually go to the blockchain to fetch the public key of the issuer, in this case IGNU. And since it is there in the blockchain, they can do that. So now, so there are various features of this system. So digital wallets are to keep the credentials. You can do selective disclosure. You don't have to necessarily give the entire information, which currently, if you give a paper copy, you have to give all the information. Non-transferable proofs. If you give paper copy to somebody, they can actually use it and get a SIM card from your other's copy, etc. This is not possible because this is cryptographically secured and bound to your identity. Zero knowledge proof based credential proofs without giving out the information. Multi-credential proof. So if you have Aadhaar, you have PAN card, and you have driving license, everything in this form, then you can sometimes prove your address from your Aadhaar. You can prove your PAN through the PAN card, and you can prove that you are capable to drive by proving that there exists a driving license in your name. So these multi-credential proofs are possible. It is very highly interoperable because of the use of the standard format of the verifiable credential, and the secure and private channel between peer. So when we do peer, holder and verifier interaction, that is secure and private channel. And also various other things you can do with this is that autofill of web pages by actually fetching information from the verifiable credential from your wallet. You can do passwordless login. You can actually use this to enter the airport and other secure facilities. So there are lots of different benefits, and there is no correlation because all these lookups are not being checked. So when I prove my other identity, other UIDI is not getting to know because it is happening peer to peer. So there is a reduced correlation, so more privacy, and then the data minimization, reduced identity fraud, this kind of various kinds of possibilities are there. So we have been trying to actually convince the other authorities to actually use this for issuing verifiable credential based other identity to holders. So then you can do zero knowledge proofs, non-transferable proofs, and this whole idea of sharing other copies at various locations or giving your other card to various places like a hotel and stuff like that can actually stop. And also this can be used as a bootstrapping mechanism for other identities. So for example, if I can prove my other identity, then my university will give me the degree. Without that, university may not give me the degree as verifiable credential. So I can use the other to bootstrap my other credentials. So it's a new age digital identity and credentialing mechanism. It's being looked at various parts of the world. So no more hassles of scan and upload, various other features, but I will just go through that. So in the 54th convocation of IIT Kanpur, we gave degrees through this system to 1,723 people. And here you see Honorable Prime Minister is pressing the button, after which the degrees were pushed to the wallets of the students. Obviously, the students were asked to download the wallet app from the Google Store, Play Store, or Apple Store, so that they can actually immediately receive their degree. So the Honorable Prime Minister talked about this. Here is the.
I now request the Honorable Prime Minister to remotely launch the blockchain-based digital degree transmission.
So here is the digital degree transmission. So all students, 1,723 students got their degrees, and you can. So this is what the degree looks like. So I can, so this is what the sample looks like. The one on the left is IGNOU degree, and on the right is IIT Kanpur degree. And then the Prime Minister was happy with this, and then he actually told the Honorable Minister of Youth Welfare to actually do the Pradhan Mantri Rashtriya Bal Puraskar also on this. So we did that last January. And then we actually have done IGNOU, and the National Institute of Technology, Rourkela, is next. Also we have been talking to this organization, NEGD, who has organized today's program today. And we are trying to explain to them what the advantages of this are. Also, we are talking to this Samarth system for integration of digital certificates. Also, we are talking to the NTA, the National Testing Agency, to actually issue the JEE scores on this as a verifiable credential. So there is a lot of activities going on. Now, I'll very quickly, I think I am running out of time, but I'm going to very quickly talk about this Kaveri blockchain property registration by what we did in the government with the government of Karnataka. So here is a multi-stakeholder blockchain, and then there are audit nodes, one at IIT Kanpur, one at the STPI, and the registration of property documents is done. And here the identity is bootstrapped from Aadhaar eKYC, or if somebody does not want to use other eKYC, they can do other KYC. And the identity then becomes part of a private public key pair, and the private key is now put in a smart card. So we designed the smart card, and this smart card is used to actually access information or get, provide consent to be party to a registration process. So this is what the application interface looks like. We'll not go into that. So here is the status. So last year, we launched this 20th November 2021. We did the pilot launch of this, and in 2 districts, and then this was moved to 6 districts. And so far, about 14,971 cards have been issued, and there are total deed registration is 9,367 so far. There has been a problem with the smart card availability due to a chip shortage, this smart card. So therefore, this thing is currently in abeyance. So there are currently 6 districts that are running this, but it is supposed to be rolled out to the rest of the state of Karnataka. So this is the Kaveri blockchain. And then we are also doing work with the Lucknow Development Authority for securing land registry documents. So, see there one of the problem was fake registration outside the system, insider attack by the people who actually used to control the IT system that was containing all the registration information. And therefore, we are using, again, blockchain as a trust layer. So hash of all records are pushed onto the blockchain, and data integrity is maintained through the permission blockchain network. And the actual PDFs of all the documents are actually put in a interplanetary file storage system. So here, September 22 is our goal to actually finish this. So we are currently in the process of bug fixing, upgrading user administration and onboarding, and a new web portal launch is happening. And then the entire thing will be done in September 22. And then we also did another project with the government of Karnataka on e-procurement. So there, the idea is that there are multiple e-government procurement portals across the country with no shared view. So suppliers have different logins, different identities in all these different systems. And therefore, when you want to vet a supplier, experience certificates, what projects they have done, which projects they have not done well, etc., that is very difficult to find from multiple different information sources. So we integrated this permission blockchain network between the EGP systems across the country. In this case, by across the country, we mean 4 states, excluding Karnataka. So Karnataka plus 4 states at the moment. So governed by terms and conditions decided by a consortium of these EGP systems. And it acts as a national duplicated supplier data store with award of contracts and work experience integrated to this information. And the suppliers will be available to retrieve all relevant data across all the GP system. So currently, it went live this year in January. The government of Karnataka has onboarded Telangana, Andhra Pradesh, Chhattisgarh, and Assam. And the banks that have been onboarded are SBI, Canara, and HDFC in this project. And then we actually also have a lot of work going on in our project on cryptocurrency forensics. And I don't know if you have seen in the news. So we are actually developing a crypto forensic, which will allow us to, for a given cryptocurrency address, to track where their money is flowing, whether it's going through an eKYC compliant exchange, whether it's going to a mixer service, and so on. So this is an investigative tool for the police that we are developing, and it has a lot of intelligence with the help of machine learning algorithms to actually process the data, look for malicious activities, suspicious addresses, and so on. So that's something that is slightly different from what I wanted to share here, because here the point is that how blockchain is useful in e-governance, creating trust purveyors of or provider of the service. This is a very important thing for e-governance, because the trust is one of the most important part in creating a frictionless system, having a trust deficit is certainly a big friction that we want to avoid. And if we can avoid the big friction, then our activities will actually gain velocity, and therefore the economic activities will also gain velocity. So that's the philosophy with which we actually doing this project. The cryptocurrency, that's another talk, but I have quite a bit of misgivings about the way cryptocurrency operators, the exchanges are behaving in India. And therefore, we actually worked on the forensic tool in order to make sure that law enforcement has something which is not as expensive as international tools like chain analysis, etc., to actually investigate crypto frauds and Ponzi schemes and so on and so forth. So I'll stop there, and I don't know if you have time for questions. Otherwise, I'll stop here.
Professor Shukla, thanks a lot. There are a few questions after Vinay sir and yours keynote, so I'll take up a few. One question is, yeah, okay. There are some major challenges they are talking with respect to blockchain scalabilities. How can that be overcome?
Yeah, so scalability is a big issue with blockchain. So, what we are currently doing is we are using something called a layer 2 blockchain. So in a layer 2 system, what happens is that not all transactions go into the main blockchain, but a summary of all the transactions go from a side chain to the main blockchain. And this can scale, like for example, if you look at the Polygon network, Polygon's blockchain, that is 65,000 transactions per second. That's that I would say pretty scalable for most of the needs. So yeah, so scalability is a challenge, but the solutions are also around the corner or actually being used. So I wouldn't worry too much about the scalability at this point.
Right. Okay. Another question is, what is the future of private DApps in India?
Private DApps, well, the DApps, all the stuff that we are doing in like Karnataka and etc. It's actually a decentralized application, so you can call it a DApp. But normally, when we use the word DApp, we talk about this Ethereum DAOs and Ethereum decentralized applications and so on. But any blockchain that uses a smart contract is basically a DApp. So of course there will be private DApps, various organizations, especially when the organizations create a consortium, like for example, supply chain. Then any application through which you are passing your transactions through, that is basically a DApp, and it could be private. It doesn't have to be public. Only people with permission can actually access or make calls to the methods of the smart contract. So yeah, so that is fine.
Okay, I'll take one last question, although there are quite a few. Okay, what exactly was the role of blockchain in the IIT Kanpur degrees being sent digitally to students?
No, so the blockchain is only for actually for verification. Not for the degree. Degrees are sent through a system. IIT Kanpur basically had a portal and where students register, and the degree was sent. Every degree sent, the hash of that degree is also there on the blockchain, but that is not necessary. That's only for data integrity purposes. The only use of blockchain is when you verify. You have to look up the schema of the credential and to understand to interpret the information, and also you need to know the public key of the issuer, in this case IIT Kanpur, which can be looked up from the blockchain. But once you look it up, you can cache it. So after that, you don't even have to look at the blockchain.
Thank you very much, Professor Shukla. And thanks a lot, dear audience. You've been writing a lot of questions, and I encourage you to write more questions. I'll take them up after the next session. So thanks a lot, sir, once again.
Thank you.
And now we would like to, move on to the next session. And for that, I would like to invite Mr. Jayavaradhan Sambedu to talk about how blockchain can enable governments to make policy decisions that will drive useful innovations in future and effective delivery of public services. So over to you, Mr. Sambedu. You are the co-founder and CEO of Curl.tech. You have over 18 years of experience in banking and financial services IT. You also have had successful stints with the Deutsche Bank, Royal Bank of Scotland, Union Bank of Switzerland, Citizens Bank, and Societe Generale. At Societe Generale, you headed the Emerging Technologies and Trends division within their innovation setup and led many initiatives in machine learning, AI, augmented reality, blockchain, etc. So over to you, sir. Sir, you're on mute.
Yeah, thanks, Swati. If you could just stop, I can share my screen.
Mm-hmm.
Yeah, hi all. As you know, I've been a practitioner in the blockchain space, and Swati, can I just check you're able to see the screen? And
You're audible, and your presentation we can see as well. Go on, sir.
okay, thank you. So what I would like to touch upon is one, I think the other panelists who spoke before me did not have sufficient time to touch upon some of the foundations of what makes blockchain this interesting. And then how does it really, end up helping us create a lot more use cases. And I will touch upon briefly about what are the sort of use cases that I've been involved globally in this space, and what are the different applications that I have had an opportunity to collaborate with certain central and state governments, and what could be the potential use cases. That's what I would like to cover within the setup of what we're doing. So this buzzword has been quite prominent, right? What is blockchain and DLT? And all of us hear about it. And of course, there's been an explosion of this, although it may have started from a cryptocurrency perspective, but there's a whole lot of traction around this entire blockchain and distributed ledger. But then without understanding what really makes this up, it's going to be very difficult for people to appreciate where are the use cases coming from and what really is the reason why this trend is catching up in a very big way. So essentially, if you have to look at what a blockchain component consists of, three things are things that you'll need to understand that help make something as a blockchain or a distributed ledger system and ensures that the trust can be bought in without having centralized actors who serve as custodians of trust. I mean, whether it's your bank account or any such agency where there are central organization, there are centrally controlled. If you have to decentralize it, the way it was done in one particular use case, which happens to be the Bitcoin, and which is the inspiration for many other blockchain and DLT systems, these are the three components that exist that help it, make it more secure. So let's touch upon a little bit about what each of these are so that you'll be able to appreciate it more. And then I'll lead you to a use where you can actually see the application of these coming together. Now, on their own, cryptography, digital signatures, and consensus protocols are technical topics, and we will not go too deep into them. But it's worthy to understand these innovations already existed. Right? These are not brand new, but the way blockchain and distributed ledger systems utilize them is very unique. And that's how there is a uniqueness to the way how it's caught up. So what is cryptography? So cryptography, it's from the Greek terminologies, cryptos means hide something, and graph is basically to write. That's the root word for write. So when you're sharing information with another party, how do you ensure that that information is not directly intercepted by someone and it cannot be discovered what exactly we're trying to share? Now, the very basics of this go back a lot into our own scriptures, where there's a lot of hidden cryptography in our own scriptures and the way communications were sent across. Of course, Julius Caesar was quite popular. He popularized one particular form of exchanging information in the armed forces. You have the Caesar cipher, as we call it, the cipher shift. So if you have an alphabet starting from A to Z, and let's say you just shift the alphabet by a certain keyword, now without knowing the keyword, the same sentence will look extremely jumbled up, right? Because if an A is now mapped to an E, and the entire sentence, the way you do it, if that key is changed, just because you introduce something in the beginning, the whole, the way the sentence is rendered would change. This sort of technique, although was very basic, cryptographic systems are far advanced. We have multiple ways in which we could exchange information with each other. Now, I won't again go detail into it. I will share this slide, and there are some links which you can go through. But essentially what you can understand is a secure hash algorithm, which is an underpinning algorithm on which many of the distributed ledger systems would work on, essentially can take any input document and convert it into a unique 256-bit information. That's like a digital thumbprint of what that particular engagement is. It could be a terabyte data. You could just bring it down to one simple hash function, and any small modification to the input would dramatically change the output, and that's what makes this very unique. So just as an example, so this is a common sentence most of us would probably learn typing. Now, as you can see, the first sentence produced an output. Again, you don't need to understand what the output is. You just need to understand for a given input, there was a particular output that was generated. Now, between the first sentence and the second sentence, all there was changed was a simple addition of a full stop and nothing more than that. But as you can see, the output of the second statement has nothing to do with the input statement for the first one at all. So any small changes to the input dramatically changes the output. That way, you know that if there is any tampering that has been done with the original source information, you know for a fact that the output would never match. And that is one of the fundamental pillars on which distributed ledger systems work. Now that we've covered the cryptography part of it, the second part is something quite a few of you may already be comfortable with. These are digital signatures. Now, digital signatures are an equivalent to the standard way in which we were proving our identity on systems. Primarily, we would have given a username and password. And as you know, in any typical mechanism, hacking this is pretty simple. I mean, there are, of course, that's why you're recommended to use much more stronger passwords. So it's not easy to crack. Whereas digital signatures rely on discrete mathematics to basically provide you a mechanism through which two keys, which are mathematically linked, and ensure that there's a public key that you can share with everyone and a private key that is only used to decrypt the way information was sent to you. This, as a simple one, you may have worked on logging into your system, whether it's your VPN infrastructure or your banking application, in which many banks now provide. You would have seen this name as an RSA, right? An RSA-based algorithm or an RSA-powered something. Now, what RSA is basically a mathematical function, and it relies on properties of prime numbers. Now, as you know, in mathematics, the prime numbers are not uniformly distributed. It's very difficult to predict where the next prime number would be. This is what this entire digital signature, at least the RSA mechanism, leverages. What it basically utilizes is when you ask a computer to multiply two numbers, it can do it very, very quickly. And that's what they're designed for, right, eventually. But if you give it a number and ask it to reverse the function and say, what were the two prime numbers that really created it? Now the computer has to spend some time figuring out what were the primes, what could potentially match, and it will have to go through certain computational payload for it to reach that conclusion. That is precisely the crutch that is utilized by digital signatures. So that's why you see your RSA tokens will keep recreating every 30 seconds because the hacker has less and less time by when they have to actually break through whatever is the system that is used. So this is digital signature. Again, something very essential in the blockchain-based system because every node, when it is engaging with the blockchain system, digitally signs whatever information it's trying to send. Again, we will not go into detail into these. But just as I'll leave you with this, what Bitcoins and other systems that are inspired by Bitcoin and blockchain-based systems or DLT-based systems use something a lot more comprehensive called the elliptic curve digital signature algorithm, which is much, much more advanced than RSA for the same bit size, basically. There is enough material I've added to this at the end, which you can go through and understand what the differences are. But I'll leave you with one thought. For the same bit size, if you ran an RSA versus an elliptic curve, mathematically, the amount of heat that is generated by the RSA system is warm enough to warm a teaspoon of water. But for the same elliptic curve encryption, you have to break it. The amount of heat theoretically that it would generate can boil all water in the entire oceans, right? So that's the significant difficulty between hacking through or breaking a elliptic curve encryption versus what's there in the RSA. And the third one, I think the Professor Shukla also spoke about, is consensus. Here, the information itself is distributed across multiple systems. So there are no single points of failure. Now, if anyone has to modify something and make it as the accepted truth, then they can't just do it in one or two systems, which are the pitfalls of centralized systems. Instead, you would have to at least manipulate more than 51% of all systems. And considering that these systems itself would be kept more private, it's very difficult for someone to breach through it. So now when you combine all these three, what you get is an absolutely powerful system, which is cryptographically protecting whatever was being sent, digitally secured by digital signatures, and ultimately distributed across multiple systems, which is what makes blockchain and distributed ledger systems unique. Now, again, consensus protocols are a slightly more technical piece. Now, when you apply all of this, what could be the what could be the applications that could come out of it? Now, one of the common applications and most of the things that were spoken about as use cases are all something called smart contracts. Now, again, smart contract is again not a brand new invention by the Bitcoin world. Smart contracts existed before Bitcoin as well. But what makes it absolutely secure is when you deploy a smart contract, which is nothing but a digital equivalent of what would be the terms and conditions of your real world contracts, and combine it with cryptography, digital signatures, and consensus, it makes it absolutely foolproof to carry out very complex transactions, which otherwise would not be possible through the traditional mechanisms. So this is what is the basics, I would say. If you get this largely, you would almost get almost 90% of the type of use cases that are getting built on these very foundations of what it is. So smart contract use cases, we'll come back to this later. So I would like to take you through one of the use cases that I led. This was a global use case that I led in 2017. On the basis of this use case, there were multiple consortiums that were created. So I would like to play a small video. I hope your microphones are on.
Sandeep, we are not able to listen. We are not able to hear voice.
Mr. Jay, actually the audio is not there for the video.
Oh, the audio is not being played, is it?
Initially we were able to hear, but then it just went.
Oh, is it? Okay. This is directly embedded within the setup. Let me just check if it's a... Okay, let me know if it's still not played. I'll share the direct.
No, it's not. Yes, it's not there. Voice is not there.
Okay. So anyway, I'll then give the voiceover for this. I mean, this is now you can hear me, right? You can hear me.
Yeah. We can hear you.
So this was something called the Easy Trading Connect application that was designed for the world of commodity trading. This was something that the opening speech as well we spoke about. Cross-country transactions are extremely cumbersome because there are multiple stakeholders, multiple documents get created, and all these documents create trails. All of these need to be shipped across the world and they need to be processed. So what we solved here in 2017 was, let's say, a sales contract, and all the actors on that particular chain, we could directly get them onto the blockchain and ensure that the documents were directly created on the chain. There was no requirement for the paper trail to be created at all. Now, when you start having that, the sales contract can be created. It can directly be sent to the other party. They could digitally sign it. They could request for a letter of credit. Documents can be issued on this particular platform, and so on and so forth. So essentially, we completely got rid of the paper process itself, and we were able to demonstrate an efficiency of about 5x of what the current processes were. Now, the commodity trading industry is a $19 trillion industry, right? So because they talk about, it's about moving oil, metal, gas, agriculture, all of that happens in this industry. Now you can imagine a 5x improvement on the process efficiency is a significant game changer for them. And that is exactly why it led to creation of multiple blockchain consortiums. Today, we have companies like VAT, Comgo, VTrade, MineHub, and Quantus. These are all platforms put together. All of them were inspired by just this platform, and they've gone on to do something unique in agriculture, metals, and so on and so forth. So when I send this deck out, I think you will be able to see the embedded article, or I will share a URL for it, which you can go through when you'll have some time on this. So now coming to, once you've seen that use case, and as you saw there, what we essentially tried to do in that particular use case was remove these friction points, which is paper that was getting created. Now, if you truly look at what the use case was solving, there is a traditional, way of thinking that paper is not going to go away in international trade. But then when was the last time an agency issued something that was just purely paper-based? Now look at any document that's getting issued. Right? This is basically digital data that sits in their system, but it just put that on a piece of paper and that's handed out. But that is not really based. That is just convenience. But if you truly look at it, the data itself was digital in their system. And the reason why that data was not getting shared directly to others were primarily because there was a deficit of trust of how would that data get manipulated. And that's exactly the problem that was solved there. And that's the efficiency gain that they received. Now, if you take inspiration from that and come down to what are the various use cases that could be of interest to us. Now, government, as any large organization, definitely struggles with ensuring process improvements or processes to be handled across different stakeholders. But unlike many other organizations, governments are also accountable, need to do it fairly and transparently to the citizens. Now, the traditional ways in which the technologies exist do not really help us achieve that objective in a manner that brings in all these three foundations. And that's exactly where there are a lot of use cases that we see with blockchain and DLT systems. Now, digital identity was something that was already touched upon, and we've already seen what IIT Kanpur is working on. Now, digital identity is absolutely crucial. It's not going to be very far away where you will see, we will not be talking about blockchain come in, let's say 5 to 7 years from now, or probably by 10 years. It would be accepted that this will be a fabric that will be underlying many of our systems. Like today, we don't talk about databases. It's understood, right? We know that if information has to be stored, then it has to be done in a particular manner. On the same lines, this would become a fabric below all the other mechanisms we have for data storage to prove that nothing was manipulated or there are checks and balances that are kept in place. So that's where digital identity becomes a very interesting use case, where you will be able to control in a granular manner everything about your identity, but authorities who need to verify it should be able to do that very quickly. Very similar to the Aadhaar, right? You could go ahead and change your address or anything else, which is all within your purview, but some other agency, all they want to verify is it you who's asking for this home loan or the bank loan? Don't really need to know many other details about you. They just need to be able to verify that you are exactly the same person who that is. And instead of keeping it central where there are single points of failure, it could be much more better that beyond that, we put another layer where identity can be managed also on the blockchain. Now, patent management is a second big area where there are a lot of innovations that are possible. How do we streamline this entire process and leapfrog with the more and more digital initiatives that are coming across various ways? Patent management to ensure that intellectual property gets accumulated and seamlessly it's allocated to the individuals who need to get them. All of that, there are real good use cases for blockchain and DLT there. As we already heard from the professor before, there are a lot of experiments. I had an opportunity to collaborate with some state governments which were exploring this. Like the Tamil Nadu government was looking at the entire state family database and this entire program, what they called Nambikka Inayam, which stands for trust chain. And they were looking at many other things that could be going onto the layer. So land registration was definitely something that was explored, which even government of Andhra Pradesh carried on. And I understand it's being done out of IIT Kanpur as well. But the land registration, what we also saw was a complex problem to solve because land itself falls under the under one particular, the central and the land reforms fall under someone else, and taking title deeds and converting them into something of a valid one with concepts like Bhu Aadhar and others that were being introduced was actually a lot more processes need to be distilled. And that's where we saw the challenges, but that's where there are applications as well. So I also recall government of Andhra Pradesh was trying the vehicle transfer and also manufacturing agencies embedding from start to end the sort of use cases that they could look at, where provenance were important. Those are interesting use cases. So I had an opportunity to collaborate with the Election Commission as well. Last year, we did talks on how do they see blockchain and the voting itself. There were panelists across the world, and definitely the West Virginia related use case was discussed at length there. But I think the point here is going to a world where blockchain-based voting is not the direction that at least is being considered. What is definitely being considered is there are a lot of other processes before that, whether it is voter identity and the metadata around it, all of that, there are efficiency gains that were there by applying DLT and transparency. So that was one of the things that I would like to mention, where the larger views that were coming across, but all of this is still in discussion stages, and I don't think it's reached a stage where it's going to be pulled out. Now, healthcare. So there are a lot of initiatives within the government. We already saw COVID and how essential it was for tracking, tracing, and ensuring vaccination was being done. But if you expand this COVID itself into a much bigger initiative of becoming a global repository, at least for India, for health-related registries that can be created, then there's a lot of use cases where the information is extremely sensitive, but the necessary stakeholders should be able to receive it without fear that someone could manipulate this data, whether it is sharing prescriptions or getting the overall outbreaks that are coming up, can it be traced, tracked, and identified? So all of those, there are absolutely brilliant use cases that can be explored in the healthcare space where blockchain and DLT can play a significant role, including a universal identifier, what we may have for our health records. Document issuance and verification. Again, we touched upon it a little bit earlier. As a government agency, there are multiple certificates that are issued at different levels, and all of those issuances to verifications are a classic case for how blockchain and DLT systems can help. E-governance, the Nambika NAM project, what I spoke about, came under the e-governance setup. There were quite a lot of use cases that were being explored, including issuance of certification. Land records were all a part of the larger program that was being run there. And the final one, of course, is the CBDC. Now, there's a lot, and for India at least, while the digital payments have taken off in a very big way, and we have multiple options today, UPI stands tall globally in terms of the transaction volumes that we do every month. And while that's a big boost we already have to our payments infra, RBI has been mooting for CBDC, and we heard a notification as well in that in this fiscal year there would be a launch of a CBDC. Now, what is a CBDC? It's a central bank digital currency. It's unlike a cryptocurrency. This is going to be centrally managed by the authority that's going to issue it, but it's going to be a pure digital currency, which is just going to tie up with whatever is the fiat currency for us, it will be the rupee. And that's going to be a very big game changer for financial inclusion and many other use cases that are allied to that. Those are the sort of dramatic use cases that we can see in India. So as you can see, I've tried to cover a gamut of use cases, which are all pertinent on the very foundations that if you want transparency, accountability, and fairness in many of those, the legacy technologies may not be directly able to solve it, but introducing something like this can bring in a lot of confidence to the ultimate stakeholders within the system. Now, there's a lot of opportunity within India as well. I mean, when I started in blockchain and DLT, it was in 2014. Very few people were even speaking about this at that time. In the meetups that I used to organize and sometimes be a part of, there were hardly 5 or 10 people that used to come in. But of course, now there's an explosion of interest. There are many colleges and universities which are very seriously taking up blockchain itself as a very important technology that people should prepare for. So there is an abundance of people that are coming in with knowledge in this particular technology. Now, Web3, which is if you look at it, the standard, the web as 1.0, when it was originally launched, was all about building out systems for just peer-to-peer systems. That's it. There was really nothing more. Primarily, it was used by journals, publications, and that's that. But Web 2.0 is what has resulted into creation of multiple apps on top of it. Things like Facebook or Amazon, Flipkart. You take anything on any such application, e-commerce or otherwise, what you're engaging today is the 2.0 rendition of how the web has evolved. And today we are moving towards Web 3.0, where we are seeing an explosion in NFTs, in tokenization. We're looking at other systems, including linked to the metaverse. And that's where it's headed. So Web 3.0 itself is in a very nascent stage, and India has a massive opportunity to leapfrog it by embracing some of the applications in the space. Largely friction-free services and improved efficiency are also aims that can be bought in between. Of course, it's not a bed of roses for blockchain as well. You have to implement them. It also comes at a certain cost. The technology still, there are standards and interoperabilities that are, of course, it's much better now compared to how it was when we started, but it's still not at a level where it is completely stabilized and we could just go pick it up and do it. So there is, it's still nascent from there. The standards are still to evolve to come back and ensure that all systems with different protocols can speak together. The existing infrastructure itself may not be scaled up to allow for some of these. And of course, the volume of transactions. Scalability concerns are being addressed. We also need to be pragmatic on the type of use cases we choose for blockchain. And as a very important point that was spoken early on, every use case need not be a blockchain use case, and which is where sometimes when the hype cycle is very high, people start exploring almost every use case to be more of a blockchain one. That is not necessarily the right way to look at it. And the last point is it needs to integrate with existing IT systems. This is a point that's oft forgotten because blockchain systems will not work in isolation. And if they have to work with existing systems, then there needs to be sufficient awareness and understanding of how these integrations can happen, and necessary investments need to be made. Otherwise, this will remain a siloed project. So I have some additional appendix, but that's for further information. But if there are any questions, I can take it.
Yeah, Mr. Sambedu, I will take up 2 questions as of now. Okay, first one is, maybe request you to elaborate on CBDCs, whether in Indian case, it is going to be for wholesale or retail users, or it will be a combination of both.
So the way the CBDC as a system would work, and the closest, there are few countries which have explored this to a much detail than what we have done. I mean, of course, even I've been a part of some of the consultations that our own government has been working on. The digital yuan is by far one of the most audacious projects that were done by China. China already had a very good ecosystem with WeChat and WePay and everything else that was embedded. So they were exploring how the digital yuan could work. So if you really look at how the digital CBDC for India could be coming up, there would be 2 modes for it. One would be the wholesale approach, which would be used by institutions, and this would be them engaging directly with the concerned banking and financial institutions. That's one way the CBDC would work. There would be a separate rendition of it in the form of retail CBDCs. This is what potentially you and I would use for intra settlements. So the CBDC itself would be split up between 2 separate use cases. It won't be the same overall that's coming in, but we still have some distance to go before it can be launched. But I'm also equally curious to see in this fiscal year if you're going to launch something that's something very audacious, and with where UPI and the entire UPI stack is, I think CBDC is going to be much quickly embraced than what other countries would ever be able to do. But that's the answer to your question.
Right. Okay. Thanks. Thanks a lot. I'll take one more. Could you share your thoughts on the impact of standardization on innovation and growth? I think 2 people have asked this one earlier also.
So the standards, I've had the opportunity to be a part of Bureau of Indian Standards as well as the International Standards Organization. I can tell you there were in standards, it's extremely difficult to arrive at it because the overall, the technology itself is nascent. I mean, we have a 10-year probably systems. When you look at many other systems, they've had a much more longer duration for us to arrive at what the standards are. Many of the things in the standards we are still grappling with is definitions and what exactly do they mean, because they don't mean the same thing across different countries. So unless we arrive at a common lexicon of saying, okay, this is what we really mean by this, it's very difficult to figure out protocols and systems that are going to work on it. So at a standards level, I can tell you the conversations what we're having are very much at a high level to understand, aggregate, and figure out where it's headed. But we can disconnect innovation and growth from standardization itself, because standardization always is an afterthought than beginning. Because if you start off with standards, we will never be able to innovate or carry on with growth. Once we've reached a particular critical mass, it's then going to be much more easier to then talk about standards and arriving at what are the competing protocols, pros and cons, and what do we in between. Otherwise, it's going to be stymied. For example, in our own view, what we've seen is when SHA is the standard norm, we've been looking at SHA 3, which is a lot more rigorous as some of the basic foundation blocks for applications that we are considering in our systems. We are not waiting whether this is going to become a standard globally. The hope is it will become, but we've already started looking at those things. So innovation and growth, I would disconnect from standardization, which is an independent activity and required when we want to engage with other systems. But for local applications that are getting built out, we are not seeing that as being any challenge. We are continuing to innovate, and there's significant growth in this space.
Mr. Sambedu, I'll take one last question to do the justice to so many questions. How do we implement blockchain in legacy applications in the state government?
Yeah, so in fact, this was one of the biggest challenges we noticed as well when we were looking at whether it is Nambike NIM or whether it's with the government of Andhra Pradesh when we were looking at it. Even within the government, even central or otherwise, there are pockets of how the IT strategy itself has been evolved. Because the IT strategy has been localized to how that application needed to be built, who were the stakeholders, and how was that going to be sorted. This was not only a problem with government, I can also tell you in the commodity trading space, which is at the cutting edge of innovation, even there, when we were trying to engage and work with International Chamber of Commerce or whether we were looking at phytosanitary certificates authorities, it was not easy. So while the purest approach is to embed a blockchain or DLT application inside a system like a legacy-based system, what we've realized is that is not going to yield results. We've looked at disconnecting them, building out these pockets of information which are not connected to legacy systems, build out what the use case is, what the absolute relevance is, and we found ways to bridge them via APIs and other mechanisms to connect to legacy systems. That way, we've tried to break away the challenge of embedding these solutions into the system, but allowing us to build out and then ultimately connect to a legacy system and secure that connection. That way, there's a best of both worlds. And this has come after experience. Of course, initially, we all felt it would be very easy to do it. But now we've matured significantly and we've realized that build it out and then connect it to via APIs and secure them. That way, you are not upsetting what's already there, but you're leveraging it for what the future needs to be built up.
Thanks a lot. Thanks a lot, Mr. Sambedu. With that, we will move on to the next session. So we thank you once again. So now it's been some time. All of you have been very patiently sitting with us and listening to our speakers. And I'm sure you've all learned quite a bit. We will take some time. We'll take a short pause here and do some fun gaming activity here. So I'm going to request you all to sit back and follow some instructions here. Just 1 second. There's going to be a link that flash on your screen, and there will be a user pin that will be available. 1 second. Okay. Can somebody let me know if the screen is visible?
Yes, it's visible, Swati.
Okay, great. Thanks a lot. So with that, I'm going to start the game. So I'm going to request you all to log on to www.kahoot.it and enter the game pin, which is 2585692. 2585692. I will also write it in the chat room. Kahoot.it. It's probably going to ask you to send in a nickname or something that you would like to have. Great. It looks like you're able to follow it. Once again, log into www.kahoot.it, Kahoot.it. Enter in your game pin, which is 2585692. I'll wait for exactly 30 seconds more, and then we will start. Excellent. I am going to start now. So let's see how well you know blockchain. The first question is, what is a blockchain? Is it a centralized ledger, an exchange, a type of cryptocurrency, or a distributed ledger on a peer-to-peer network? And the clock stops. And the right answer is a distributed ledger on a peer-to-peer network. We'll go and see the scoreboard here. So PS is leading the scoreboard with 908 points, followed by Vishal, MK, DD, RK, AMDR, and Jayanta. We move on to our next question. What was the blockchain created for? Smart cities, fast travels, anonymous payments, or to play games quickly? And time's up. The right answer is anonymous payments. Let's take a look at the scoreboard once again. So this time Vishal is leading with 1,826 points, followed by DDR, KMDR, SK, Jayanta, and Tiger. Okay, move on to the next question. How are blockchains linked? Cryptography, connection, gum, or a software? Time's up. So the correct answer is cryptography. 44 people have answered that correct. There are 8 people who also chose a software. Interesting. We'll take a look at the scoreboard. DDRKMDEA is the top scorer right now with 2,720 points, followed by SK, Tiger, Harevix, Ajay Verma. Okay, move on to the next question. What are the benefits of blockchain? Transparency, tamper-proof, security, or all of the above? This one's an easy peasy one. Time's up. Almost everyone's answered it correct. All of the above is the right answer. A quick look at the scoreboard. SK is leading the scoreboard with 3,627 points. Let's go on to the next question. In which areas is blockchain currently being used? Is it all of the above? It's agriculture, banking, or healthcare? Time's up. The correct answer is all of the above. Okay. A quick look at the scoreboard. SK is leading the pack with 4,557 points. I may move on to the next question. What's the term for when a blockchain splits? Is it a merger? It's a side chain, a division, or a fork? This might be a little tricky one, but yes, the right answer is a fork. Interestingly, majority has chosen a side chain in this, is this answer. Okay, let's take a look at the scoreboard. SK is leading the pack with 5,493 points, followed by Tiger, Pondicherrian, NLUD, and PS. All right, we go on to the next question. This is probably the last question. Which of this is not a characteristic of a blockchain network? Being consensus, finality, expensive, or immutability? Which of this is not a characteristic? And that's correct, as expected. The right answer here is expensive. With that, look at the scoreboard. SK is the top scorer with 6,384 points, followed by Tiger, PS, NLUD, and Manoj. Alrighty. This is the last question now. What is a cold storage? A place to hang your coat, a private key connected to the internet, a desktop wallet, or a private key not connected to the internet? 6 seconds left. Be quick. And the correct answer is a private key that is not connected to the internet. Majority of them have got it right. With that, let's take a look. Who was the top scorer? So the winner is NLUD, followed by PS, Manoj, and the runners-up are SK and Vishal. May I please request, well, very, very congratulations to all of you. And may I request if you can write your actual names in the chat room, we would all like to know. So thanks a lot. And with this, we will move on to the next session. Puneet, can you help me unshare my screen? I'm unable to do that right now. Okay, 1 second. I think now it works fine, right?
Yes, it's fine now.
Great. Okay, thanks a lot. All right. So with that, we'll move on to our next session. Our next session is going to discuss how to leverage blockchain for sustainability and open innovation. And for this, we have two speakers here. They are both from UNDP, Ms. Petrovic and Mr. Rawad Risk. Ms. Marina, you are an alternative finance and technology expert with UNDP's Istanbul Regional Hub. You provided hands-on technical expertise, advisory support, and market intelligence to over 45 UNDP offices, national partners, and governments around the world. You're the co-founder of the Alternative Finance Hub, which is an internal startup run out of the UNDP Istanbul Region Hub for Europe and CIS. Also, our second guest for today is Mr. Rawad. Mr. Rawad, you are the project manager at UNDP Lebanon and a member of IRH Innovation Team and the All-Fin Lab. So over to you, both of you, for this session. Thanks a lot.
Thanks so much, Swati, and hello, everyone. As Swati said, both today Rawad and me will present UNDP and our projects in DLT and blockchain technology. Also to say, I'm calling from Zagreb, Croatia. It is currently there 7 a.m. So sorry, maybe for my voice or for looking a little bit sleepy. It's just very early for us on this part of the world. So how are we dividing our presentation? I will go first through the first few slides and then Rawad will take over. So maybe if somebody can, should I share my presentation or if somebody else?
Sure. Sure, Miss Marina, you go ahead. You'll have better
I don't know,
control.
Ravad, maybe if you can share it because my screen is, I don't know why I cannot share it here. Maybe if Ravad, you can share the presentation or anybody else, maybe Swati, you.
All right.
We have a storm in Zagreb for the last 5 hours, so I'm even happy that I have a Wi-Fi, to be honest.
Okay, just let me know if you are able to see the screen.
The other presentation.
Okay.
I will share.
Okay, this is the only one I have. 1 second.
It was sent yesterday.
Mm-hmm. Okay. Mm-hmm. All righty, give me 1 second, please.
Mm-hmm.
Sharing that screen for you.
Thank you so much. So while we're just waiting for the presentation, also I would like to say and thank you to the organizers for inviting us, and of course to all of the speakers for sharing part of their experience with DLT and crypto and blockchain. I think this is also great learning for all of us, and I really hope to have some connections once we are done and once we leave the event. So today we are presenting how UNDP is using strategic innovation in blockchain technology to tackle some of the world's most complex challenges. So Bad and I, we are part of the UNDP innovation team. Next slide, thank you. We are part of the UNDP innovation team, and we are co-founders of the UNDP Alternative Finance Lab. Alternative Finance Lab works with different innovative finance and technology projects for development, which we are using to empower governments, partners, and communities through the tailor-made solutions. We have started to explore and work with the blockchain 5 years ago, but of course, this is sort of not the end of our journey because we are always learning and growing as technology advances very rapidly. So today we will present a glimpse of what we are doing, what we did, and of course, we will invite all of you to contact us if you want to know more or if you want to get in contact, of course. So first, why blockchain and DLT and what is there for the UNDP? So the development challenges are growing rapidly every day. So we are currently in the midst of, I think, second or the third crisis this year. And for UN, business as usual solutions are no longer sufficient. Second, addressing SDGs can be advanced by using the smart technology and by blending innovation, technology, and development. That's why in UNDP Alternative Finance Lab, in UNDP Innovation Team, we are recognizing the value of innovation that we can blend with technology, as well as working with a private sector companies like some of you that we already heard today, in order to find new solutions that will help us to address this crisis and development challenges. So the UNDP motto is leave no one behind, and we definitely think that technology can help us to address it much more faster and with sort of the efforts. So, okay, I will now share a few of the examples together with Ravad, how we're using the blockchain. Each of them is different because, again, we are in the innovation team and we're trying all the time to innovate and create tailor-made solutions. So I think this is the next slide. Thank you. So, yes, thank you. So track and trace. So the first question we asked ourselves is, what if we could make fair trade even more fairer? The next slide, thank you. Yes, so we are now presenting track and trace projects that we did with UNDP Morocco. It's called Argan Oil, with UNDP Ecuador, the other bar, and with UNDP Serbia, Food Bank and platform Plate by Plate. Next slide. So track and trace, this is our flagship project. It's a project, we call it the first blockchain chocolate bar ever. And the name of the chocolate bar was the other bar, and I can tell it was very delicious, and it still is. So we were using the blockchain technology for tracking goods from farmers in Ecuador, focusing on cocoa, coffee, and tea. We did this project in partnership with Amsterdam, a company called Fairchain, and together we were developing this first blockchain shared value chocolate bar. We also wanted to design a premium product. So it was not only an innovative product, which is a blockchain, a chocolate, but we also wanted to design something that is really tasteful, that has perfect flavors. So everybody could buy it and really experience from the first hand how technology blended with the product looks like. So how does it work basically? So when European consumers would specialize these green shops, organic shops, they can buy the other bar. Through the other bar, when they scan the QR code, which is on the other bar, they can trace every single ingredient used in chocolate bar and ensure that it really was sourced fairly and sustainably. As a result, the price reflects the impact on the ecosystem, as well as the actual production and export costs, with farmers that now, in this end, are receiving a much bigger or the greater share than they would through the other, than they would through the other methods, like their current method or even like the fair trade methods. The chocolate bar was also created from the Ecuador's most exclusive cocoa beans, and we were working with the farmers from the Ecuadorian Amazon. So why did we choose to use the blockchain here? Sorry. In this case, it was not only like, again, creating innovative products that is very tasteful, but also we wanted to really empower the farmers. In this case, by using this smart technology, like complex technology, farmers could see what is their gain, how much was earned, how much it goes to them. And we are speaking about the farmers that cannot read or write. So of course, all the time with whoever came in their field and whoever worked with them, if they were uneducated to understand what is happening, then of course they could not be empowered, even with the fair trade system. So by using the smart technology and giving them mobile phones, like smart mobile phones, they could really track, okay, what is my cost? How much I earned? How much it was sold? And of course, by using blockchain, we can connect directly with the buyers from Europe. So this is the true empowerment. So in this system, blockchain was used to simplify very complex processes and reveal the impact in a very clear and transparent way. During the UN and UNDP annual meeting at Davos, I hope you all know about the Davos, so our administrator, Achim Steiner, introduced the other bar as a future of development. So the future of development should look like this: innovative products blended with technology that anybody can use, taste, feel, and of course, then empower others. So the similar project, please, the next slide. So the similar project we did, thank you, with women cooperatives in Morocco. So they were working with cooperatives that were producing argan oil. So argan oil is one of the biggest exports from Morocco. We're using it a lot in cosmetic industry to make our hair nicer. So argan oil can fetch 250 euros per liter on the European cosmetic market. And it has tremendous economic impact on the rural Moroccan communities that are producing it. Usually they're female cooperatives. When the oil leaves their hands, it is much ready for the sale. So there is not so much sort of the interference from the middleman. So they produce it and they can go to the cosmetic market. But these producers, the female cooperatives, are earning less than 25 euros from the oil. So the middleman that is selling the product is earning 250, but the farmers are getting less than 25. And again, there is no, you don't need to tweak it a lot. It just goes from you to the cosmetic market. And of course, sometimes the argan oil is the only source of income and employment for these cooperatives and their members. So these ladies are feeding their whole families with this. So by using the blockchain technology, the same as we did in Ecuador, we will connect the female cooperatives with the end buyers by removing the middleman in this case. And again, empower them. So in the end, they could earn 100 times bigger profit than they would through the standard way. It was not only this. When you're doing it like this, so when you're putting the farmers in the middle of the market, you're making from them not the producers anymore, but the business owners. They can communicate with the cosmetic companies. They can negotiate the price. They can see what sort of the diversification products that they're getting from this argan oil. So it's much bigger empowerment than just, you know, getting to know what is your real value and how much you're earning. Also, this project was awarded as the best European project and blockchain project at that time, and it was funded through the European Commission and European Blockchain Accelerator. Next slide, thank you. Okay, what if we could transform crises into opportunities with creating digital impact currencies? Next slide, thank you. So what did we do? And I will now leave my colleague Ravat maybe to say a little bit more. We tried to, so UNDP and UN, of course, is working with the crisis area, which is, of course, potential for development. And what we are seeing then is that we have a lot of big donors coming, like the governments, foundations, investing the money, but we don't have a big sort of the involvement from the private sector or even from the diaspora, but there is a huge need. So we are trying to create the impact currencies that are connecting then, for example, diaspora with rebuildment processes and projects in their home countries. Next slide, and I'm now leaving my colleague Ravat to explain more about this other point. Thank you. Ravat? Ravat, can you hear us? Okay, maybe my colleague has some problems, so I can definitely also say. So Ravat was basically leading this project. It's called Coin, and it was done together with UNDP Lebanon. So how we started? So every time when we are starting a blockchain project, we are starting with a question, with a challenge. And then we are trying to see, okay, is really a blockchain or any kind of technology a solution for this? One of the priests also said the same thing. You cannot always rely on technology because you need to have the ecosystem. You need to ask yourself, is really like this technology the right thing to do? You're not going for the flashlight because it's very hyped, specifically crypto on the blockchain now, but you're really trying to see, okay, is there a complex process that the blockchain can address? Because blockchain in the end really works well with the complex processes that need to communicate with each other. So this is something that we did in Lebanon together with UNDP Lebanon. This is in the draft, what's called phase. We have the proof of concept. So in Lebanon, there is a serious environmental crisis with around 10 million trees that are burned annually, and only 13% of the forest area is remaining. The Coin mission was to generate awareness of this problem and to raise the funds from diaspora for development projects, including reforestation. So cedar, I don't know how much you know about Lebanon, but cedar tree is the national emblem of the Lebanon. So it's not only the climate crisis, but it's also a cultural crisis because the national emblem is being burned down. So there is a big interest from diaspora that wants to invest in tree planting projects in Lebanon. So we said, okay, let's find a company or NGO that does the tree planting, but they don't have much support from diaspora. They're missing an investment model. Let's create this Coin that we will give as a reward to all of these investments and of course, diaspora citizens that invest in tree planting. And we say to them, okay, once you invest, we reward you with the Coin. Coin value was $25. And of course, once they were collecting the coins, they could like change it later for example, air miles, or for getting some kind of, discount for the eco or organic products. So they could exchange it for some kind of, benefit from the ecosystem that we developed together in parallel with the Coin. I think this is the last slide.
That's right.
Yes, okay. I'm just stopping here. We could like to speak a lot. For Ravat also prepared a specific presentation also for the Coin. If you would like that we go a little bit further into the details. But if not, of course, we're here. These are just 3 of our projects, but we have around 15, 20 of them that we could definitely share, speak with you, And again, I'm really, really happy to be here together with Rawad to learn more from each of you and what is happening on the global level with the blockchain. Thank you.
Okay, one second, Marina. Rawad is on the participant somehow.
Yeah, sorry, can you hear me now?
Yes, we can hear you now.
I think I wasn't a panelist, so I think Marina did a great job. So just want to say hello, everyone. Just few sentences, if I may, on the Cedar Coin. So yes, one of the problems we were trying to tackle with this project was deforestation. So the country, Lebanon, was once known as a green country, but unfortunately, as my colleague Marina mentioned, we only have like 13% of greenery. That was due mainly to fires. Some of them are intentional, probably most of them. A lot of wood was used for heating. Construction affected also the trees, and we looked at one of the problems, which was with most of the NGOs and the CSOs working in the country, was related also to the aspect of transparency. So we had more than one person paying for the same tree. This is why we started looking at also what kind of technology we can use just to tackle this problem. And this was mainly the reason for starting the project. It's still in progress. Unfortunately, there's a financial crisis in the country, so it's really difficult to work on similar initiatives. So, but we wanted to encourage people to plant tree and provide them with a proof that this is a tree that you paid for, and hence this is where blockchain can play a major role. So yeah, that was just my 2 cents on the project, and yeah, over to you. Thank you.
Okay, thanks, Rawad. There was another presentation. Would you like to share? I see 2 presentations.
No, I think it's fine. Marina covered it, so yeah, it's all good.
Okay. Okay, thanks a lot. With that, we are coming towards the end of today's session, and I'm going to request Mr. Satyanarayanan Meena, sir, who's the Director of NEGD, to kindly provide the closing remarks for the session.
Thank you, Swati. Can you hear me?
Yes, sir, we can hear you.
Yeah, thank you, Swati. Good afternoon, everyone. Yes, thank you so much. It was indeed a very informative and intricate session. I hope the purpose for which Digital India Dialogue initiative has been taken to share the potentiality of the emerging technologies in respective ministries, departments has made to some extent. Now it is time for us to conclude today's DID session. I believe you all had learning and takeaway from this session. On behalf of NEGD, I want to express my generous thanks to all the eminent speakers for sharing their wisdom and experiences with us. I would like to express my gratitude to all audience for their presence and contribution to make this webinar a great success. I also thank our President and CEO, Shri Abhishek Singh, and his dynamic leadership under which DID program was visioned and conceptualized. And I would like to take this opportunity to thank Mr. Vinay Thakur, CEO NEGD, for his continuous support. And I must remark a proficient sense of gratitude to UNDP and Intel team, who always bring best of industry's practices, expertise from across the globe to make every session exclusive. And last, not the least, my entire capacity building team for seamlessly managing and coordinating the session so well. Also to awareness and communication team for facilitating to reach out to relevant audience through various social media handles. We hope to see you all soon in the next session. And with this, I will request Swati, please flash a feedback form on the screen. So I will request all of the participants to follow and fill the feedback form. And I will also request to follow us on various social media pages where we can share, we used to share various latest issues, causes on application of digital technologies, improving the delivery of citizens services. Thank you again and have a great day. Thank you so much.
Great, thanks, sir. Just to reiterate, the feedback link is there in the messages. I would request you to take a few minutes to fill in that feedback form. It will really help us improve our upcoming sessions. And also, as sir had mentioned, we have I've also shared the LinkedIn handle and the Twitter handle, and I would request you all to please follow us there, where we share all the best practices. Thanks a lot. We'll keep it for 1 minute. We'll keep the session on so everyone can copy the link, and then we can close it. Thanks very much.
Thank you. Thank you very much.